Hopefully everybody's really energized after lunch, not about to fall asleep. As you can see, I speak very slowly and very softly, so I'll lull you all to sleep. And I only have a couple of slides. I've got about 78 to make it through, and we'll see if we can make it through. So welcome to this session, In the Shadows of the Cloud. I'm going to tell a little story to start off with, and then after the story, which is purely fictional, we'll hop into some lessons or things that you can take home and do yourself. So a little bit of a disclaimer. The story you're about to hear is a fictional portrayal. While the events may be inspired by real and reality, the details, places, and names have been changed to protect the innocent. If you all remember, a couple years ago, myself and Christian Roylo presented, and we were part of an organization called Seasides Incorporated. We were a victim of the NotPetya attacks. Since then, our IT estate has recovered. We've completely rebuilt. We've moved off of Windows and off into Macintoshes, as well as building much of our infrastructure in AWS. Then we got hit by a trademark lawsuit, and I had to change the name to Seasides Incorporated. Or I might have forgot that we called it Seasides with a capital C and just made all my slides with Seasides the other way. So it's been pretty busy. It's the peak of vacation season. And last night, I got this Slack message from one of our security operations staff. It turns out that our sales operations team has stood up an AWS account that they use to help pitch our vacation packages. And it's not part of our AWS organization. It's completely separate. Doesn't use our service control policies at all. And yesterday they noticed that it was serving content to sell fake Rolexes. That sucks. So we need to get access to this AWS account, and one of the things that we could do is we could just grab an administrator account and grant ourselves administrator access via a role there. That might be a little intense and a little overkill. We could easily disrupt operations in that account or step on evidence that we're trying to gather. So instead, luckily, we have another AWS role already set up for this sort of situation that's mostly built out of read-only access. We've got CloudWatch logs and CloudWatch groups access, read-only. We also have Amazon S3 access to check out what is in the S3 buckets. We also have our config user, guard duty, AWS billing, and CloudTrail read-only access so that we can see those events and pull those back as necessary. We also have security audit access, which allows us to describe and figure out what's going on with our compute resources, as well as databases and any other cloud resources necessary. This covers most of it, and those are 8 managed policies from AWS that we just have to add into this. There's a few other things that we want access to be able to respond to an incident appropriately, though. So we created a custom inline policy, and it has AWS portal view usage. This allows us to view the usage of different resources within the organization, and I'll add to why that's important in a few more slides. We've got EC2 privileges to allow us to create snapshots and create images. This lets us image any compromised resources, such as that EC2 instance that might be compromised at the moment. We also have EBS instances, or EBS privileges for everything, which allow us to grab disks from our databases as well as our EC2 instances. IAM privileges to get and list any credentials, roles, or users that are around. And then KMS privileges to allow us to encrypt the evidence that we're looking at and transfer that out of our account, encrypt it into our new account. So that's the additional access. We'll put that in a customer inline policy at that point. And then we're going to grant ourselves access to our super secret AWS account of 1234567891012, very similar to the password on my luggage. And we have customer inline policy. We have a CloudFormation template that allows us to just send a link, and when the administrator of that AWS account clicks on it, it will run and set up our cross-account role and trust relationships that we need to gain access. They've done that for us, and now we're going to come into the EC2 portal, and we know what EC2 instance it is. So we're going to go over to that EC2 instance, create image, modify the permissions to share it with our account of 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, and I need to type the 1, 2 here left at the moment. First thing that we're doing is a web service, so we're going to grab the access logs. We want to know what's going on and when this started occurring. Sadly, we only have 11 days of logs to look at. But hey, let's start doing the world's fastest incident response triage, and we're going to gzcat access log to see if there's any successful web requests to Etsy password, maybe Etsy shadow, see what's there. Maybe they're redirecting standard in to out with a less than 2 ampersand to whatever output that they're looking for. And maybe there's some, but we're not finding that. Maybe there's some SQL injection with an ampersand 1, not finding that. Is there anything with just a colon? Not finding anything there. We're not finding anything where people are hitting an instance metadata URL, which might be indicative of a server-side request forgery, where people are using that EC2 instance to access the privileges and information about accounts and access and roles on the back end. We're not seeing anything there. So what's going on here? Maybe we can just browse to the website and see what's going on. So we browse to the website. Oh, well, let's take a look at some of the logs additionally. We're looking, it looks pretty normal. We're getting some registration pages. We're also having some successful logins through the API of verify login. We see destinations coming back. That's all good. Let's look at the status codes. And looks like we've got a lot of 400s, a lot of 500s. That seems a little odd. Usually there should be less of a balance of those. So yeah, let's go to this website and see what it is. It's pretty benign, pretty basic. It looks like just a login page, which allows you to log in or register an account. It looks like it's part of this Laravel web framework, which is openly available. Maybe there's something there. So let's try to send some malicious or some suspicious or weird things to make this site trigger an error. We're seeing a lot of errors there. And this comes up. And it turns out that this site has debug for the application set to true, which stores all of the, returns all of the environment variables as people hit that site. And right below that, we can see the AWS key ID and then the AWS secret key. This provides somebody enough access to be able to use those to access that user or role with those keys. And it looks like we've got an S3 bucket there. Taking a guess here, but it looks like maybe they had write access or were able to access that bucket and maybe drop some things in it. So let's take a look, and we're going to search for this access key ID in the IAM console and take a look at what privileges that user also has access to. In this case, it looks like this is a pretty good inline customer managed policy. Our S3 bucket is limited to list bucket, but then, or their access is limited to S3 bucket, as well as listing the bucket, but then also they can not just get objects, but they can delete them and put new objects in that bucket. Oh, I think our story is starting to come together a little bit here. And let's see what's in this S3 bucket. All right, so this looks pretty standard. We've got a handful of date directories. Maybe they're using those to set up a new vacation campaign and sales campaign for each one of those months. And then we've got this .gcp here, and that seems really out of place, being that we're in AWS. But maybe let's take a look. And there's only a JSON file inside that folder. I'm kind of curious what this is. I'm a little scared. And that's a service account credential for a GCP account. And it's for this account, for this GCP project of Laguna. And we can see the Seaside Sales Group has access to that GCP project. So we're going to come over to our GCP console, and Laguna is not one of our projects. I wonder where this is. So we don't have this. I'm curious where we should go to figure out who's standing or who's using and administrating this GCP project. So we're going to send something over to our financial controller and say, hey, we're looking into some compromised infrastructure in AWS, and we found this additional cloud account. Is anybody expensing things for Google Cloud over each month? So we're going to send them this email, and while they work on that, we still have some more analysis to do, and there's some more places for us to look at things within AWS. First, we're going to go over and look at guard duty. It turns out that they have not turned guard duty on, and that's kind of expected. This is some sales account that somebody has built and stood up separately. Look at CloudTrail, and it looks like they haven't created a CloudTrail yet. So that's not been turned on either. So we're kind of running out of options here. Luckily, CloudTrail allows you and stores 90 days of data by default. And CloudTrail is on by default. It's just that all of the data is going to the API, and you have to interact with it through the console. Now, if you want CloudTrail data, if you turn the trails on and start logging that to a bucket, that data is retained indefinitely. With CloudWatch, that is not on by default, but whenever you do turn on those log groups, that stores the data indefinitely as well for infinity. And you can configure that data to ship to a bucket as well. And then you can work and retain that data and then retire it into S3 Glacier and cold storage as necessary. With your resources, your S3 access logging, your load balancers, your NetFlow data, that's also not turned on. So all of that access and interaction with those load balancers with S3, that's not on by default. If you do turn it on, also, that stays there for infinity within your S3 buckets, or until you remove it. Guard duty is also not on by default. This is your security detection and protection. When you do turn it on, it stays on for 90 days unless you replicate that to an S3 bucket. So you've only got 90 days, and it's through the console. Luckily, with our CloudTrail data, we can start to query that through the console. So taking a look at our console, we can search for it based on access key. We know that access key ID from that debug page. Start looking into it. It looks like they're doing some reconnaissance here, describing the regions that has access to and events and such. We're also listing access points and describing things around the bucket, what kind of encryption is enabled and so forth. And you can see the username associated with that access key right there as well. This is really painful, but let's open up one of these events and see if there's anything useful. Hey, we've got an IP address here that we can start to look for other activity from. Sadly, the CloudTrail console doesn't let us search based on IP address. And we want to do some more advanced searching anyway. So we're going to write a little script to hit the CloudTrail API and pull that data back. CloudTrail's API, using the Bo23 Python package, you can just pull back the data from the CloudTrail API and reformat that as though it was logging to a CloudTrail bucket as necessary, S3 bucket as necessary. We're going to grab that in every 5 minutes, just like CloudTrail does and buckets those. And then we're going to create the directory path similar to how CloudTrail does that by default with our region, year, month, day, etc. And then we're going to output that data and wrap it in a JSON root of records and publish those as gzip JSON files. What this lets us do is, now we're writing all of this out into an S3 bucket, and we can pretend that we were storing the past 90 days of data, and then we can use AWS's CloudTrail templates for Athena, open up Athena, run this CloudTrail template, data definition, and then we can start to query this inside Athena with a much more powerful query language and with many more fields, like our IP address. So we search for that. It comes back with the same events. We also want to search for get object and put object events. Maybe we'll be able to find something here, but we get no results because S3 access logging wasn't turned on. So we have one more card in our back pocket to pull to figure out what's been going on with this account and how long it's been going on. With our AWS portal view usage privilege, we're able to go into the portal and create a usage report. And we can do that for S3, for that resource, and bucket it based on month, day, or even week or hour. And we can see how much usage we've had for S3. This gets output in the time frame that you've set, so in this case, a month. And then we're going to pull that apart and see what our usage was looking like. And it looks like something happened in July 2023. There's many more events. One kind of gotcha with view usage is if you try to pull back too many events, you'll get this error at the bottom of your S3 report or your usage report that says the report for the period and values you specified was too large, and you've tried to retrieve too much data. So you need to request a shorter time frame or make those buckets larger, maybe looking at a year or a month instead of a day or a week. Hey, it looks like finance got back to us, and somebody in marketing, Blake Gilroy, started expensing a GCP account back in February 22. So we're going to ask them, and they've given us access to, they're going to give us access to their GCP project. Now, with GCP, again, we could use similar roles to the administrator role in AWS, maybe just going with our basic roles of owner or editor, but we have the same issue that we had with AWS, which is we could inadvertently trample over resources and evidence. So instead, we're going to create our own permissions. Pretty simple. The permissions within GCP are slightly different. We want the viewer access, which is pretty simple. That gives us most of our viewage, and we can view most of the resources and what's been going on with those. We also want private logs viewer, and then with GCP, you want BigQuery user and BigQuery job user so that you can start to search that data much more in a much more fine-grained and powerful language than the Logging Explorer console. We also want security reviewer privileges so we can see the IAM privileges, and then billing manager for us to see how those resources have been being billed as well. We also want, we might want compute editor privileges so that we could stop an instance or delete one of the K8s groups that we have. And then we want IAM editor privileges to maybe stop using a service account or delete any users that have been added to this GCP project. With GCP, the logging is much more fine-grained as far as what's on by default, and as well as the time periods are much different. With GCP, both your admin activity and system event audit logs are sent to the _required bucket, and they exist for 400 days by default. Pretty much everything else that's on by default exists for 30 days, and whenever you have to turn things on for GCP, those also go on for 30 days. So the other pieces that are on by default are your system event audit logs, your policy denied, and then your debug logs and system maintenance logs. This is usually when GCP has decided that they're going to update your Google Compute service on their own, and you're like, why did my machine go down? All of the resource logs, like your VPC flow logs, your GCS usage, and your DNS, NAT, firewall, load balancer logs, et cetera, those are all off by default. GCP also has this weird thing where everything gets sent to these privileged buckets rather than a standard bucket, and then you're sending everything in a log sync to anything else that you want to search, including BigQuery. One of the good things to do is to make sure that you're sending them to a bucket as well so that you can retain that data indefinitely. So we're going to go into the Log Explorer console. It's it's a really blunt instrument to search, and we're going to search for this service account. And it looks like they've created a couple additional service accounts in the data below. And it looks like there was something in June, but most of this data, most of these events were in July 2020, or 2022, 2020, 2023, whatever year it is right now. We also have our IP address, and we're going to search it. And there's a few less events. We don't have that event from back in June. So this has given me a good feel that this activity was going on yesterday and the day before, July 19th. In the interim, our finance folks got back to us. And they said there is an Azure subscription that somebody else has spun up, Parker Quinn from the Business Strategy Group, and it's for the D-Sides project. The D-Sides project is our project that's relying upon using LLMs to have AI suggest vacations for people instead of people choosing their own vacations. Because our leadership has decided that AI will know what people want for vacation better than people know themselves. So with Azure, it's a lot easier to gain access. You just need to invite an external user and send them an email, add their email address here, and provide them the basic role, built-in role of reader access through Azure. Azure's logging is a little, in one way, simpler, and another way, much more complex and fine-grained. Azure AD logs are on by default. If you have a basic Azure subscription, you only have 30 days of logs. The more money you pay Microsoft, the longer they retain your logs. Those Azure AD logs are where you get your login ability, your authentication events, et cetera. The activity logs are for the Azure subscription itself. They tell you what has been going on with that subscription, what resources are being created and such. Those are on by default as well for 90 days. And your resource logs for, say, storage, load balancers, your EC2 instance and stuff are not on by default. Now, Azure's documentation really focuses on taking those different log types and where you can send them, not how you get them. So if you read the documentation, there's a lot of documentation on Microsoft's site around taking Azure AD event subscription logs and resource logs, sending them to an Azure storage account in blob storage, sending them to an event hub so you can have that Kafka stream send off to, say, your SIM or XDR instance or some other thing to perform processing like Datadog or what have you. Or you can send them to a log analytics workspace, which is actually backed by Google or Azure storage, and you can grab that data out of the log analytics workspace itself or from blob storage, or you can send it to the Azure monitor and grab that from their API. Now, what the documentation is not good at telling you about is that you can grab all of your Azure AD events that exist based on your service tier from the Graph API. And you can just write a Python script and grab those and pull those back as well. You can grab the subscription logs from a REST API. And then there are lots of PowerShell methods and commandlets which will let you pull data from all three logging topics so long as they're enabled and those logs exist. In this case, this account, we don't have any reason to think that it's in scope with the rest of our intrusion. And we're just going to search in the log analytics workspace for that IP address. And it's never been so nice to see no results from a search. So we're going to go back to our web logs and verify that this is the time frame that this IP address has been active. And it looks like, yes, July 19th and July 20th is all we have, at least for our 11 days of web logs that we had. So we're feeling pretty good now. We're ready to remediate. We're going to go into the AWS console, and we're going to deactivate the key, not completely delete it, because we want to leave that around so that we can come back and say, hey, when was this key created? Maybe what other access did it have access to? And we don't lose those permissions policies as well. And then in GCP, we're going to come in and we are going to disable that service account, not delete it as well, so that we can make sure that we have the other, we have that additional metadata around what permissions that had at that time. So that's the end of my fastest cloud incident response story ever. And while this is fictional, it's kind of an amalgamation of many of the stories that the incident response teams at my organization at Palo Alto Networks have been encountering. We see a lot of these instances where really large organizations end up having a cloud instance stood up, a cloud account stood up, or a GCP project or Azure subscription stood up by somebody outside of the IT and security organizations. It's not part of the organizational policies, and sometimes it's just somebody's personal account, and they were getting frustrated with the service control policies that were in place, and they just stand up and start using their own account instead. And they'll start to expense those back to the finance group. There's almost always a tie back to finance and expenses. The other thing that we see is, since these organizations aren't engineering or IT organizations, frequently those web services will have been stood up in debug mode. And they'll be leaking credentials, or there will be some other misconfiguration that allows you to gain access to things. The server-side request forgery method is, I feel like, heavily played, but I see the debug and the keys or service account credentials from your environment much more frequently than that, to tell you the truth. You know, in a lot of organizations, well, I feel that in my experience, if you're in a technical organization, from the startups that I've worked in, usually it's about when you hit the point of 100 people, there's probably an account that somebody has that's a personal account that they're using for a business critical service. So if you're in like a more technology startup, I guess like an engineering company or a robotics company. If you're in a bigger organization, it takes a little bit longer, but if you have 10,000, 20,000 employees, you probably have a few of these accounts that you don't know about, and it's kind of scary. So what can you and what can we all do about this? So one of the first things, and I didn't really hit upon this explicitly, but one of the first things to do is agree upon what your incident response strategy is. And I think this is an overlooked area for a lot of organizations, and it comes down to how are you going to approach finding compromised assets? Are you going to remediate them as you go and continue to play whack-a-mole and just deal with one at a time the entire time? Or another strategy that I've seen a lot of organizations take and use is this concept of a rolling remediation and eviction. So they're going to scope and they're going to continue scoping, but there's a lot of pressure for them to start remediating and stop the bleeding. So they're going to investigate it maybe for a week, maybe for a month, and then every month they're going to roll through and remediate what they know about. The approach that I've always preferred is to do a wholesale analysis and eviction at once, where you continue doing scoping until you've figured out the entire extent of compromise in as much data as you have available to yourself. Now, the downside of taking that approach is if you're dealing with a ransomware or destruction scenario, you may only have 1 or 2 or 3 days to start remediating and containing that damage from that actor. Doing a much more deep dive into your forensic images of those hosts and such might take 48 hours or more for each one of those hosts that you find compromised. So you've got to play the balance of those two items. The other thing that I wanted to hit upon was, what do you need and what should we all be preparing for as security professionals within our organizations? So one of the things that I recommend is that everybody has 2 accounts, at least 2 accounts per each cloud provider, being one a security account, and you use that security account in order to gain access to additional compromised accounts. And if you are using cloud services within your organization already, then you would use that as the hop-off point into your organization's allowed cloud services and accounts. The other thing, and from my experience, I manage all of these for Unit 42, and Our bills are pretty low for all of these. For Azure, for GCP, for AWS, it's a little bit more expensive. That's kind of like where we have a lot of data being stored, and it's still just a few thousand per month. Most of them, it's under $100 per month. For our sandbox accounts where we let people play and stand up flaws.cloud or vulnerable resources or try to gather evidence from those, see what that would be like, those accounts are usually around $10 or $20 a month. It's extremely cheap. Sometimes there will be a little bit more cost associated with those, where we have to pull down, say, a privileged AMI machine image that costs $400 a month or something. And hopefully you'll be able to bill that back to whatever department is using that AMI image. The other things that you need for AWS, have those CloudFormation templates ready to go, both for administrator access and then for your investigative role. The investigative role having mostly read-only access and then some additional privileges that you need, such as the view billing resources. And then also having those Python scripts ready to go for CloudTrail and CloudWatch. CloudWatch you can also grab from the API, even if it's not logging to a bucket. And you can replay those logs and then drop those into a bucket as necessary to perform long-term analysis. And get used to using the AWS command line interface in Boto 3, which is the Python module for AWS. For GCP, you want some Terraform with the permissions that you want, probably admin privileges, editor privileges to the project, as well as your more fine-grained and mostly read-only privileges. GCP, you want the gcloud command line interface, as well as their Google Python packages. The Google Python packages do take, I'd recommend definitely spending some time playing with them. Google really likes to use iterators versus just passing back the REST response, and getting used to iterating through that data and working through that data in that way is, it takes a little bit of time. With Azure, there are you'll want Terraform for the access, and then there are lots of PowerShell scripts available to perform log acquisition and pull that back. They're pretty comprehensive as well. I'm personally fairly allergic to PowerShell, and the Azure command line interface is nice, and there's a lot of Azure Python modules as well. And Mystic Pi has a lot of packages ready to go to perform analysis based upon the log analytics data that can land, as well as Sentinel data that are extremely helpful. Oh, okay. The last couple points, so usually whenever you buy security tooling, and like your SIM or your XDR tools, those are made, and the configurations for those and integrations for your cloud systems are made to set up, say, an SQS topic and start publishing events from create object events in S3, or a pub sub that is looking at create events inside GCS. And then in Azure, you'll have that Kafka Event Hub set up and streaming those same events as well from the log topics over into your SIM. But those are all made to go from, hey, we bought the SIM and we're looking at things from here forward. Or we've integrated the SIM to this cloud account and we're looking at things from today forward. By using those scripts from CloudTrail, CloudWatch, or if you already have data going to S3 buckets and you discover an account and you need to do forensic response looking at data from the past, if you set up an SQS topic and set it for create object events, when you do a copy of that historical data, the SIM will still ingest it. However, a lot of the machine learning and more analytic-based detections, usually those are based upon ingest time, not event time. But you'll be able to ingest all of those historical events, and then you just need to start performing analysis, looking at the event time of things rather than your ingest time. The last piece is decide upon your primary cloud, whether that's GCP, Azure, or AWS. And then within that primary cloud, set up imaging hosts that allow you to perform light forensics for Linux and Windows and such. There's a lot of triage scripts, use OS query, what have you. And then also your more in-depth forensic imaging using DD to grab that image and then loading that into Axiom or Xways or what have you. The next piece is you want to have templates for all of your core data sources, firewalls, the different cloud providers, and different kind of security tools that you may have. Create those templates so they're ready to go within whatever your primary cloud is and whatever that data platform is that you're going to use, whether that's Athena, KQL for Azure, or BigQuery in GCP. And then the last piece is partner with your finance team. Like I said earlier, usually whenever people stand up these cloud accounts, they will want to expense those back, even if it's $50 a month, $100 a month. They're going to start expensing those back. And by looking at what things are expensed through your organization, you'll be able to discover that somebody has a recurrent bill for $20 a month to AWS. So that's the extent of this session. I wanted to say thank you. These days, mostly, I'm an engineering manager in front of many teams. I don't really do a lot of the work hands-on myself. Sometimes I get to help people out, but I need to extend thanks and kudos to my team. They're the ones that have mostly discovered or figured out a lot of these things, and I'm learning from them. Additionally, the consulting team has a lot of engagements. We're usually dealing with 2 or 3 cloud engagements every week, and I get to hop in and be the rubber duck for them to run concepts past, and sometimes they figure it out by themselves. Sometimes I get to help out a little bit. And of course, thanks to the B-Side staff and everybody that came and attended this session. Thanks all.